Hello everyone! In this session, we will go over how to write X classes and M classes in the Onfinity system. Now, let us go through the agenda for this session. We will be learning about the PO class. To write in X class or M class, the PO class is mandatory, as X classes are inherited from the PO class. PO class is basically the persistent object class, which is responsible for saving and deleting the records in the Onfinity system from any table. Then we will learn about the X class and how we can generate the X classes. There is a tool available in the Onfinity system. With the help of this tool, we can generate the X classes for any table. X class is basically a property class for all the columns for a particular table, which provides us the get and set properties for all the columns. Then we will get to know about the M class. M class basically provides you with the trigger functionalities, like before save, after save, before delete, after delete. And if we go through the more advanced topics of that, then that can also provide you the doc actions as well. Then we will learn how the M classes should be named, and what the naming conventions are for an M class. Then we'll get to know about the default constructors of an M class, and triggers that we'll cover in this session. And then, how to get the messages from the M class, and how we can display the messages to the user via this M class. There are some points that you have to keep in mind while creating the M classes into the system. So if the naming convention is not according to the recommendation by the Onfinity system, then the M classes will not work. There are certain rules that you have to follow, so it depends basically on the prefix of the table. For example, if the table name contains 2 characters before the underscore, the first underscore, then, in that case, 2 or less than 2 characters to be precise. Then in that case, the name of an M class should be M, and the rest of the underscore should be removed from the table name, and remove the characters before the underscore. For example, in this case, the table name is AD underscore WF underscore node. Then the name of the M class will be MWF node. In this case, underscore AD is removed from the front, from the beginning, and the underscore is removed from the table name as well. So the name of an M class is MWF node. Similarly, we have another example of the AD underscore table, where the name of the table is AD underscore table. In that case, the M class is named as M table. The underscore and the characters before the underscore are removed and assigned to the M class. So in the case of module, the recommendation is for a prefix of 5 characters and the underscore afterwards. So the prefix will always be provided by Onfinity for creation of a new module. So in those cases where the number of characters is greater than 2 for a table, for example, here as you can see, the name of the table is VA01 underscore sales order. So in this case, the name of the M class should be MVA01 sales order, where the underscores are removed and M is appended in front. So this will be the case for all the M classes that you will be creating for the new tables that will be added by the users. So in this case, as I mentioned, the name of the M classes is very important. It has to be according to this format. Then another thing that you have to keep in mind is the entry in the module management. So you have to do the entry in the module management on your development system. This entry will be checked when you are running any particular M class for a table and want to trigger some functionality. In that case, it will check the entry in the module management for the prefix, and according to that, it will load the assembly and execute the logic that you have written in your M class. Now we will see practically how the M classes and X classes are used with the partner kit. Here we have the partner kit that we have already had a session on earlier regarding how to set up partner kit. If you missed out on that, please check that session before on how to set up this partner kit. So I have this partner kit that is already set up. In this partner kit, we have Vienna Advantage SVC, and Vienna Advantage Web Projects. M classes and X classes have some folder structures that we have to maintain when we are creating processes, M classes, X classes, callouts, or pages. So M classes and X classes will be positioned under this Vienna Advantage SVC project, where we have these properties, references, bin and obj, which are just temporary files. So in Vienna Advantage SVC, what we will be doing is we will be adding one folder with the name as model. So this model folder is added over here. So all the X classes and M classes that belong to this particular module and module prefix that we are using right now is VA001, which is the demo module that we have created for this session. So in this VA001, in Vienna Advantage SVC project, I'll just go to the properties of this project, where we have changed this assembly name and default namespace earlier when we were setting up the partner kit. So this will be set up according to your module prefix. So now, in this model folder, we will be adding all the X classes and M classes related to VA module prefix. There are few things that have to be considered when you are working on X classes and M classes. For example, in this Vienna Advantage web, there are references. So there has to be added the reference of the first two projects from the solution file itself, Vienna Advantage and Vienna Advantage SVC. Otherwise, your M classes will not work. So you just need to go to this projects and solution, just select these Vienna Advantage and Vienna Advantage SVC and click on OK. So these references should be there in the Vienna Advantage web project. Now, the first step that we are going to follow is we will be creating the X class. As mentioned earlier, we have this tool which will be used to create this X class and M class. I will just run the project. So it will start with a login page where we log in with the role as system administrator. I log in as system administrator as we have to create the X classes for our tables that we have created for this module. So this is the landing page for this instance. In the menu, if you type X class generator, as you can see, there is this X class generator tool. With the help of this tool, we can generate the X classes for our tables. So when I click on this X class generator, it will open this page. Here you see there is one field where we have to select the table. So we have to select or search for a table name here. So let me just check the tables that we have created for this session. Here in this menu, we will search for database schema. We have all the tables that we have created in the system, whether for the modules or the already available tables in the system with the framework or any other module. Those will be found in this database schema screen. So here, as you can see, there are 1837 tables. So our module prefix that we'll take in this example for X class and M class is VA001 underscore. So I'll search with my prefix. So as you can see, we have these two tables, demo sales order and demo order line. So I'll be making use of these two tables for this session. So you can find these table names over here. So if I search for my demo order line and demo sales order, these are basically the names of these tables. So you search for this demo sales order. Here we have two buttons, one is generate and another one is cancel. So when I click on generate, it'll show you an info message which says the X class is generated and this generate button is changed to download. So you click on download, it'll open or it'll download this X class onto your local system in the downloads folder or whichever path you have mentioned for your download files. Similarly, I'll do it for the other X class as well, demo order line. I'll click on generate again and that message displays. And I'll click on the download button. So these two files are downloaded onto my local system. So if I go to this path, I can see those files over here, which we just generated. Copy these classes and go back to my partner kit. Here in the Solution Explorer, in the Vienna Advantage SVC folder, in the model folder, I'll paste both of those classes over here. So now I have the X class with the sales order and the sales order line, which are the two tables that I have created. Now, as you can see here, this X class is inherited by the persistent object, and the rest of the class contains the properties get and set for all the fields or all the columns that I have in that respective table. So what I will do is in the namespace section, the default namespace will be Vienna Advantage.model. This namespace has to be changed to the module prefix that we are working on. So I changed the namespace here as VA01. Similarly, I will go to the other X class, and here I will change it to VA01 as well. So this is again inherited from the PO class of the framework. Now my X classes are ready. We do not need to change anything else in this X class. The only thing is when you are updating certain functionality. For example, right now I have 10 columns in this sales order table. Earlier I had 10 columns in this table. Later on, as an enhancement, or as a change or a bug fix, there is a requirement where we must have 2 or 3 more columns in the table. In that case, we have to generate the X class again and update the X class in this partner kit, because those changes in the column level are also required to be catered in this partner kit. There can be other changes as well where you are changing the length of the column. For example, any database changes, which is going to impact a column at the database level, you need to generate the X class again. So in this case, we have this X class that we have generated just now. So we have added this X class, and we have all the properties for these X classes in this partner kit in the model folder. The next step is to write an M class for these tables. So I will create an M class first for the sales order. So as mentioned earlier, the naming convention is very much important for the M classes. X class is already generated by the tool that is available in the framework, but M classes have to be named manually. So in our case, this is a prefix that is greater than 3 characters, VA001 underscore. So in our case, the name of M class will be appending an M in front and a prefix. And then the name of the table, sales order. So underscore will be removed and M will be appended in front. So this will be the name of our M class for sales order. So I will just add this M class over here. I will change the access modifier over here. And the namespace, I will keep it as VA001 and save it. So this is an M class that I have started to create. This is the first step where you change the access modifier and change the namespace accordingly. And then the next step is to inherit this M class from the X class like this. Then it is again showing some message. So as it shows, this does not contain a constructor that takes 0 argument. So in this M class, basically there are 2 constructors that are required. So what I will do is I'll create those 2 constructors like this. The first parameter is context. So I'll write the variable name for this one. And the second parameter is the primary key of the table. So this is my table name. So I'll just copy it here so that I don't make a mistake. And this will be the primary key of this table. And the third parameter is transaction, which we will be covering later on, and inherited from the base as underscore context, and VA001 underscore table name, variety, and underscore TRX. So this is showing some errors over here. As context and transaction, it didn't find. So when I focus my cursor onto this context and I press the options to check what are the available options and show potential fixes, I'll press Ctrl and dot. So this is showing by using the namespace vadvantage.utility. So this context is available in this namespace. So I will add this namespace over here by using Ctrl and dot. And then we have another TRX object. So I'll again press Ctrl and dot. It is showing that use the namespace as vadvantage.database. You can type it manually over here in the top where we have defined the namespaces, or you can press enter by clicking on this available fix. So another constructor which you can write as with the name of the class. I'll do the same thing. The first parameter is context, and the second parameter is data row, which is not available. Again, I'll press Ctrl and dot. It is showing use the namespace system.data, so I'll use this one. Variable name and transaction. Then base and underscore context data row and transaction. So these are the 2 constructors that are required in all the M classes that you will be writing for your modules. So the first step is to change the X modifier of the M class, change the namespace according to your module prefix, then inherit your M class from the X class, and then add these two constructors for the M class. So I'll put a breakpoint over here, so we will see whether our class is being called when we are going to save the record in this table. Then I'll run this project again. So it will take us to the login page where we again log in with the system administrator role because we have to do entry into the module management for our module prefix so that our M classes and X classes start working. So later on, when we'll work on with jobs, callouts, etc., this module management entry is required for those sessions as well. So I'll search for module management in this menu. We'll open the module management screen. So in the module management screen, as you can see, there are a number of records already available. These are the modules that are installed from the market onto this instance. So what we will do is we will create a new record. The name of the module, let's say Demo Order Module. The description of the module is not a mandatory field on the development instance. So when we deploy this module onto the market, we'll define the description and all the other fields. But right now, the only field that requires the name of the module, the version of the module, which is a mandatory field. Assembly name is also required. Without the underscore, we need the prefix here and in the namespace as well. Then the module prefix with the underscore V, A001 underscore for our example. So we'll just save this record. That is the entry in the module management that is required. So I'll close this. And now in the menu, whenever you do any changes on the AD side or in the module management, you need to do the cache reset. So in the menu, I'll search for cache reset and click on OK to do the cache reset. And then I'll just log out from the system administrator role and log in with the role to which I have provided the access of the screens for which I have created the X classes. So let's see if I log in with this user, which has access to that role, which is Ideas Inc. admin. It will take us to the landing page of this user for this role. So here I have not defined any widgets or set up my dashboard yet. So I'll go to the screen which we have configured. Let's say this demo sales order. This is the screen where we have linked those tables for which we have created the X classes. So as you can see, I already have one record available on the screen where I have the document number, date ordered, the customer location, and a panel on the left-hand side. The description is there, and in the status section, I have the subtotal, grand total, and these fields are available. So I have already applied the breakpoint on my constructors for the M class. So if I change something, this is a demo order for, let's say, Customer Sky Corp. So when I save this, as you can see, my constructor is called with this ID column. So when I run this, my order is getting saved. So now what we want to achieve with the M class is some kind of validation, as it's already mentioned, the X class, the M classes, the usage of the M classes. So M class is basically for the trigger actions, before save, after save, before delete, or after delete. So we'll make use of this grand total, just for our example. Let's say this grand total field is 0 right now. So if I enter any value here manually, let's say if I enter a value of 5,000 over here. So I need to decide or display a message to the user, whether I can allow the user to save the record if the user enters the value in excess of 5,000, or allow the user to save the record if the value is less than 5,000. So we'll use the M class to validate that when the user saves the record. Let's observe this in action. Here, there are override functions, the abstract functions that are available. So if I write here protected override, as you can see here, we have this before save, before delete, after save, or after delete functionalities. So we will be going through the before save first. So it has one parameter as a new record. So I'll put my breakpoint over here, remove it from the constructors, and return as true. So in this case, we have before save, which is returning a bool variable. So my return type is bool, so I have to return either true or false. Then I have one of the parameters in the before save function. So if I want to validate, as I mentioned, if my amount is exceeding 5,000, then we don't want to save the record. To achieve that, we have inherited this M class from the X class. So this X class provides all the properties. So whatever the name of the column you have created, so in our case, let's say this grand total, we will be writing a condition in this. If grand total is greater than 5,000, then return false, like this. And we also want to display the message to user. Let's say log.saveError. Right now, I am not picking the messages from the message window, but the recommended practice is to use the messages. I will show that in the next point right now. So let's say amount cannot be greater than 5,000, like this. And the second parameter, I'll leave it as blank. This is the additional message if there is any message you want to append. So I'll just run this, build the code, and let's see if it is working or not. So we have applied a condition on the grand total of the order table. If the total exceeds an amount of 5,000, then we are displaying a message to the user that the amount cannot be greater than 5,000. Now, I will log in with my tenant credentials, after which I'll open the screen demo sales order from the menu. On this screen, there's a field for the grand total. We have applied a condition based on the amount in the grand total field. Currently, the value displayed is 1,000. If I modify it to 4,500 and save the record saves successfully because the condition specified is for a value greater than 5,000. Now, let's say I change the amount to 5,500 and attempt to save the record again. This time, an error message appears, stating that the amount cannot exceed 5,000. That behavior is defined in the code within the M class before the save operation. So, the outcome depends on the condition that's been implemented. As it stands, if I enter a value slightly above 5,000, the system prevents me from saving the record. However, if the value is anything less than 5,000, the record saves without issue. Therefore, the system's behavior is determined by the conditions specified in our code, specifically the logic implemented within the M class before the save action. For this specific field, we have set the rule that if the value exceeds 5,000, the user cannot save the record. We returned a false value at that point and displayed the message to the user. The messages used currently are static, which is not the recommended approach. We will use the message screen to implement culture-specific messages instead. Message implementation will be covered in later sessions. That was simply a demonstration of how to validate specific conditions using the before save logic within an M class for any table in the module. There is another option to consider. Using the new record variable, you can also validate data based on whether a record is new or being updated. For instance, you might want to allow saving data without the 5,000 limit when an existing record is being updated, but enforce the limit for new records only. To implement this, I will add the condition, if new record, along with the existing condition. Now, I will execute the code. This combined condition will only apply to new records. Since we already have a saved record in the system, updates to that record will not be affected. In that case, the system will allow updates because the condition is specifically designed to restrict saving new records with values exceeding 5,000 only. Now I will log in again with my tenant credentials and navigate to the screen demo sales order from the menu. On this particular record, if I enable this toggle and then change the grand total to, for example, 6,000 and save the record, the system allows the update. You can enter values exceeding 5,000 because the check is now only applied to new records. Saving that record is permitted. However, if I create a new record with tenant organization and select a customer, for example, customer standard, and then enter a value greater than 5,000, like 8,000, and attempt to save, the system displays the error. This is because the condition we implemented is specifically for new records with values exceeding 5,000. That illustrates how the M-class before save logic functions. It depends on your specific requirements for setting the conditions in the before save logic, dictating how you want to save the record, or whether you want to restrict the user from saving the record into the system. Now, let's proceed. These conditions can also be applied based on specific columns or fields. Another option is if is_value changed. This allows you to validate a particular column. For example, if the name of the column is VA001_grand total, we can check for changes in that specific column only. If there's a change in the grand total field, we will prevent the user from saving the record. However, if the user modifies other columns like description or customer, we will allow the save. I will copy these conditions and modify the messages. For instance, I'll change the message to "You cannot change the total" and run the code. What we have implemented is a check that prevents the user from changing the value in the grand total field. To demonstrate, I will log in with the tenant credentials that have access to this screen. After logging in with my ID and password, I will navigate to the Demo Sales Order screen from the menu. The current logic prevents users from changing any value in the grand total field. To illustrate, if I change a value in another column, such as the description for customer standard, and save the record saves successfully. However, if I change any value in the grand total field and attempt to save, the message "You cannot change the total" appears. This is because the M-class before save logic is configured to prevent any changes to the grand total field. These are some features available in the before save logic, or the M-class, for these trigger functions. I will now comment out this code. On the screen, we have two tabs linked to two different tables, VA001 sales order and VA001 sales order line. I will now create an M-class for the sales order line as well. To do this, I will click Add Class and follow the same naming convention for the order line, which will be M followed by the name of the table without the underscore. So VA001 sales order line.cs. It is important that the name is correct, otherwise the M class will not function. I will add it, change the access modifier, the namespace, and the prefix of my module, and then inherit it with XVA001_sales order line. Again, regarding the two default constructors, I will not focus on writing the code extensively. Instead, I will copy the constructors from the other class and change the name of the class accordingly. These namespaces are also unnecessary, so I will add the required namespaces using the vAdvantage utility. That includes the vAdvantage.database for transactions and system.data for the data row. My primary key is sales order line ID in this case. This is the M class for the order line table. First, we'll examine the structure of the table, specifically what fields are present in the order line table. Based on the available fields, we will then develop a logic defining what we can accomplish using M classes for this specific order line table. Regarding the order line, We aim to understand the standard functionality for the sales order screen within the application. Specifically, on the order line, there is information such as the product, the UOM, and the product's prices. The instruction is to log in using the training credentials. The next step involves navigating the menu within the application. I will search for the demo sales order screen. This screen consists of two tabs, the order header and the order line. Returning to the order line, it contains information such as the tenant, organization, order details, product, and UOM. In a separate section, quantities and prices are located. Clicking on a new record reveals the product field. If I select a product, for example, Netcom, I can then input the quantity. For instance, if I enter a quantity of 2, with the quantity ordered also being 2, and set the price at 1,000, then after entering these values, I save the order line record. To calculate the line net amount and the line total, we can multiply the entered quantity by the entered price and display the result in the corresponding fields. This can be achieved using a callout, which we will understand later in another session. However, for now, we will achieve this calculation of quantity and price and set it in the line net amount and line total via the M class in the before save logic. Currently, when we click Save, the record is saved, but the line net amount and line total are not calculated. Therefore, let's examine how to implement this in the M class before save logic within the sales order line. Writing protected override before save in M class. The return type will be a bool, so I will return true. We have the quantity entered in the column named VA001. It is important to know the names of the columns. Next, we need to get VA001 underscore price entered. Then, we will multiply the values and set these values in line net amount, and in either line total amount or line total. A variable can be taken here to perform the calculations and set the values in these two fields. Currently, I am setting the same values in both fields, but you can incorporate your specific requirements or additional functionality based on the tax amount or any other values you need to save in those fields, or you can implement your calculations based on your own logic. Now, let's see this code in action. I will build the code and then run this project in the before save. We have performed the calculations, so when saving the record into the order line, it should multiply the quantity by the price and set the resulting value in both the line net amount and the line total, as we have implemented in our M class before save logic. Now, I will log in with my tenant credentials. From the menu, I will navigate to the demo sales order screen. On the order line tab, if I toggle it, there is an amount section containing the quantity entered, quantity ordered, and the price entered fields. If I change the value of price entered to, for example, 500, and save the record, the values in the line net amount and line total will be updated. This update is the result of multiplying the quantity entered by the price entered. If I change the quantity entered to, for example, 5, then save it, the values calculating to the line net amount and line total will be calculated based on the quantity and price entered. This demonstrates what we have achieved using the M class before save logic on save. Currently, for this order line, we only have one line for Netcom, which includes the price entered, quantity, and the line totals. Suppose we have multiple lines in this order line table, and on the order header, if I toggle it, we see the grand total and subtotal in the header section. Until now, we have been manually entering these values. What if we want to calculate them based on the order lines? For any number of lines present in the order line tab, Whether there are 2, 3, or more, we may want to calculate, or sum, all of the line totals, and then set the resulting value in the order header's subtotal and grand total fields. This is also achievable using the M class. Let's see how we can accomplish this using the M class. We will write protected override and now use the after save functionality. In the after save of an M class, which also has a return type of Boolean, we see two parameters. The first parameter is new record, and the second is success. New record functions similarly to how it behaves in the before save function, checking whether the user is creating a new record or updating an existing record. If a new record is being created, this value will be true. If an existing record is being updated, this value will be false. You can base your logic on this variable. Another parameter in after save is success, which indicates whether the record in before save was successful, meaning it is present in the after save. You can also write your logic based on that. Now, if it is not successful, we do not want to perform any actions. However, if you want to display a message to the user in such a case, you can write a message here to be displayed. Otherwise, you can structure your logic in a way that works according to your specific requirements. If it is successful, meaning our before save function is returning successfully, then we want to set the total of all the lines present on the second tab to the grand total on the first tab. In this case, we will obtain all the IDs. There are two ways to accomplish this. The first approach is to leverage an M class, so we do not have to write any insert or update queries, and instead leverage the M classes. For example, I will collect all the line IDs using mtable. Now, using Vienna Advantage Model, .getAllIDs will fetch all the IDs saved on the second tab. As you can see, it has three parameters, including the table name, which in our case is VA001_sales order line. We need to specify the name of the table for the second tab. Then we include the where clause, which we can pass VA001_sales order_ID equals to plus get VA001_sales order ID. This refers to the ID of the first tab, which is linked to the second tab through a parent-child relationship. Finally, we add comma get_TRS. The get transaction object can be found within the M class itself. Now we will declare a variable, for example decimal of total amount, and initialize it to 0. Then, we will implement a loop through these order line IDs, as there can be n number of lines associated with the order header. Here, we will add a loop, integer of I equals to 0, I less than order line ID dot length, and increment variable. Inside the loop, we will create an object of order line equals to new. Then get ctx, order line IDS from the first index, or the increment by the I variable, get transaction. So we have created an object of this M class. Then we will add the total value using plus equals to order line. Get VA001_line total. This will execute within the loop and add the total amount into this variable based on the number of lines. Then we have to set this value on the header tab. To do this, we'll create an object of the first step, MVA001 sales order. That is our first table's M class order equals to new sales order. The first parameter is context, followed by the primary key of the first table, get VA001_sales order ID, and then get _TRX. So now, we have created an object of this table sales order and pass this value, which means it will fetch all the details of this particular record into this object. Now, once we have all the data for this total amount, we will set the values in the grand total field VA001_grand total and set the value of this total amount here. Then write a condition, if order.save. So now we are saving the data here onto this order table, based on the total amount that we have calculated from the header from all the lines. We can write any message here, and we can return false if this save operation does not work. Now in this case, we have written after save logic and checked whether the before save was successful or not. If it was successful, we are getting all the line IDs from the child tab, calculating the sum, and then setting this value onto the first tab. There are two fields, and let's say order.setVA001 underscore, and we have a subtotal field as well. If we want to set the same value in this field, we can do that as well. Now we'll build this and check whether we have written the correct logic or not. We will now run this code. Once we log in, the code should sum all the line totals onto the header tab, into the grand total and the subtotal field, when we are adding lines against one order header. This is the logic we have written in the aftersave for the order line tab. So let's log in with the credentials to the tenant. We are now on the landing page. If we navigate to our screen, the demo sales order screen, we can see two tabs, as seen earlier. On the header tab in the grand total section, I will make this value 0. I have that logic there, where I have set it to not update the values. Let's set this value to 0, so that we know whether the totals are updating from the order line onto this header tab. If we go to the order line tab, we can see one line entered. If we go to the amount section, we have the value of 2,500. If we change this value to 600, the total, line net amount, and line total on save are calculated to be 3,000. If we go back to our header tab, we can see the subtotal and grand totals are now updated. Currently, there is only one line. If we add one more line, for example, any other product, say this one, with a quantity of 2 and a price of 2,000, then on save, the line total and the line net amounts will be calculated as 4,000. In this instance, we have two lines. One line has a total of 3,000, and the other line has a total of 4,000. If we navigate back to our order header and check the totals, the subtotal and grand total add up to 7,000, which is the sum of these two lines. Similarly, if we add multiple lines onto this order line tab, our logic written in the after save will calculate the sum and set those values onto the order header in the subtotal and grand total fields. This is the case of insert when we inserted a new record. If we update something, say, if I change the value here to 2,500 and save it, the line total becomes 5,000. In this case, 5,000 plus 3,000 should equal 8,000, which should be updated on the order header because we have written the logic in the after save. We haven't applied any specific check for the new record, so it will work for both insert and update operations. The next scenario is when we have to delete a particular line, where we have the option to delete the order line. If I delete the second line, which has an amount of 5,000, I now only have one line, which has a total of 3,000. If I go back to my header, my totals are not being updated. This is because we haven't written any logic in the delete section of the M class. We can use the after delete function of the M class, which is another trigger available in the M class. By utilizing this, these totals can be calculated on deletion as well. Let's see how we can do this in the after delete. I will add another override function here, protected override after delete. In the after delete, we again have the success variable, and it has a return type of Boolean, so we are returning the value as true. In this case, we will also check if we have success in the before delete, then we will return success in case of failure. I have applied a check for not, and I have now written this code here. I will add one more common function so that I can keep the same logic in both after delete and after save. This allows me to reuse the code I have written, let's say update header, and I will copy this code from here and paste it over here. In this case, I will call, if not update header, then return false, as we are also returning a value of true or false from this update header. Return true if it is successful. We have called this on the after save. Now we will call it on the after delete as well, so that we get the totals correct at the order header. I will build this code and run it. What we have done now is write a lot of logic so that it sums up the total of all the lines and updates the total on the header, whether the user is creating a new record on the order line or deleting a record from the order line. Let's see this code running now. Let us log in with the tenant credentials, Ideas Inc. admin, and the password for this user. Then, let's examine the code that we have written in the after save or after delete to see if it is calculating the proper values on the header tab for the grand total and the subtotal. If I navigate to my demo sales order screen now, we can observe that the values are being updated on this header tab, specifically on the order tab. Here, we can see the changes, with this grand total value getting updated. If I return to my order line tab now and toggle it, I can see one line present with a line total of 3,000. If I create another record with a quantity of 6 and a price of 300, then upon saving this record, I will obtain the line at amount and the line total, which is 1,800. Once the record is saved, it will update the value here to 1,800 rupees. If I go back to my order tab now, I can observe that the subtotal and grand totals are being updated. With these two lines, I have the values as 3,000 plus 1,800. If I create one more record here, for example, any FC connectors, with a value of 8 and an amount of 500, then when I save the record, this line total and line net amount will be calculated as 4,000, with 4,000, 3,000, and another line of 1,800. My total comes out to be 8,800. With the after delete logic that we have now written, if I delete one of the lines here, this 1,800, my total should now be 7,000 on the order header. If we go back to our order header, we can see that it is also working in the case of deletion, because we have written the logic for the after delete as well. Based on this, you can try to write your own logic in the M classes to update or apply validations on save. In the before save, you can validate certain data to ensure that the user is correcting valid data. Then, we have the after save, where we are updating some values on another table. In the after delete, we are also updating values in the header. It depends on your requirements to determine what you want to achieve in the before save, after save, or after delete functionality. As you can see, we have not written a single query. We have utilized the M classes and the X classes, written object, and we are retrieving the values of all the tables and columns with these properties of the X class. With all the column names available here, we do not need to remember complex queries. We can simply write these get and set properties of the X class and write our logic based on them. Regarding the X class and M class, we have created an X class using the tool, and we have also seen how the M classes are created in the partner kit for your modules. That concludes this topic of X class and M class. You can also create your own X and M classes for different modules by utilizing different functionalities. Based on your requirements, you can write these X classes and M classes on your own. This concludes this session. Thank you for attending.